We'll talk about the observer pattern in this presentation. Observer pattern again is about decoupling. It's about open-closed principle as the force behind this principle. What does it do? It defines a one-to-many dependency between an object and of course the ones that want to listen to it, so that when the object changes state, all its dependents are notified and updated automatically. Let's understand what this means with a little example. Let's say for a minute we have a particular document which is going to keep changing. This could be an object that contains certain value. We could have different types of views. We could have a graph view, a tabular view, a chart view, and so on. The user may change the data of the document at any time, but we want these views to be reflecting that particular change. So you want to keep all these views in sync with the change to the data, but how do you really remove the coupling between the data and its dependencies? Let's look at one example of this. Let's first of all say we have an object which is called a stock object. So I got a stock object equals new, let's say stock, and this is going to represent some kind of a stock. We're going to generate a random value every time it runs through it. So let's say we're going to specify a stock object and we'll say stock.start to get the stock data change in motion. So let's go ahead and create this code so far. So let's go ahead and say stock. We're going to put that into the example class. This is a package that's good enough. Let's go ahead and write the start method. And within the start method, let's say we're going to create a thread and just keep repeating the values over and over and over. So we will say thread dot, let's say start, we'll create a new thread. So we'll say thread dot new thread. Well, in general, it's not a good idea to create a thread. It's better to use an executor service, but in this example, let's not worry about that. We'll keep the focus on the interfaces and the interdependencies for now. So I'm going to go ahead and create a runnable, and in this case we're going to specify, we'll call it as generate a price. That's all I'm going to do here. It is going to generate a price value. Well, what does the generate price do? Generate price is going to create a new price value. So in this case, I'm going to say while true, this is going to go on for a long time. We'll say sleep 1 second. So we'll give a little sleep method for ourselves. And the sleep method is going to be simply taking a milliseconds, and it's going to say thread.sleep for that particular milliseconds. We'll just simply suppress the exception within this, and this is going to simply do the sleeping. So after sleeping for a second, let's go ahead and say output for now, and we're going to specify, or let's say math.random, and we'll create just a random value for the price. Well, if we run this little code, we're going to notice that every time, every second, this is going to produce a new price value and keep counting it. But of course, I got to start the thread that I just created. So let's go ahead and say thread.start, and this is the thread.start to start the thread. Great. Now, if I run through the code, you can see that every second it's generating a new value. But of course, I don't want to print the value within the stock. That's a poor idea. So what we're going to do here instead is we're going to create the random value that is going to become the new value that we just created. But the value may be used for different purposes in different areas of the code. So one such user of this most likely would be, maybe a display object. So we'll call it as a display stock, and the display stock says display equals new display stock. We'll call it display stock. And what does this do? Well, it wants to receive a data and keep printing it. So let's create the display stock. This is a UI level class, let's say, and this is going to have a method, let's say, called display, and the display method is going to display the stock value as it finds it. But for this to work, of course, we need to depend on a stock object. So we are going to say, we're going to specify the stock object we need to depend on. Well, the display stock can keep asking for the stock value, but that's not very efficient. Instead, it's better for the stock data to tell the display when it has a new value. Well, for that to work, we have a display method, and the display method could simply say double, let's call it value, and this could simply display output value, for example. Well, that's great so far. We have a display which is going to display the value, but how do we use that in the stock? We could say, for example, stock dot set display, and then this could become the display we are interested in setting. Well, this would result in a set display method that is going to have be created. And of course, whenever the stock price changes, it could call the display on it. So let's go back here to the code and say, well, now that we have a new value, we can say display dot display the value and the value that we are interested in displaying. So if we do all of that, when we run the code, we would notice that the displaying value happens between the display, so we could see that the value being displayed. Maybe just to prove that it's coming from here, we'll simply say stock value colon, and then we will display the value here. Notice that's from the display stock. So when we go ahead and run this code, you can see it is displaying the value. However, there's one problem in the code right now, and that is the stock is going to fail the open-closed principle if we introduce yet another display that we want to add. Well, if we introduce a new display, maybe a display that's going to only display stocks over a certain level, or maybe a different form of display, well, that's going to come and break the stock class. Poor stock class doesn't have to concern with it. So what do we do? How do we deal with that? Well, in order to deal with that, we're going to decouple, and we're going to use the dependency inversion principle for that. So the very first thing we're going to do is we're going to remove the display stock from within the dependency of the stock. And let's go back here and say we don't have that method anymore. So we'll go back to this code and remove the set display for a minute. And we will come back and see how we can benefit from this decoupling in the code. So of course, this is not going to work anymore because we don't have a set display, but that's okay. We'll come back and learn about it in a minute. We'll go to the solution here. So what we're going to do here is we're going to introduce an observer pattern. So the document we are interested in is going to implement an observable, and then we are going to send the notification to an observer where we can have different kinds of observers. So in our example, we're going to go back to the stock and say this is going to implement, well, in this case, extend from an observable. Well, Java util package already contains an observable, but you can also implement your own. And reactive programming also provides, takes this further into a more interesting observables. So this is a concept that's pretty widely used in the industry. So we have an observable right here. And what do we do with this observable? Well, whenever a data changes, we're going to do a couple of different things. When the data changes, all we are going to do is simply say notify observers, and we can tell the observer that something really has happened. If you examine things that we have available, there's an add observer in the observable, there's a clear change, there is a delete observer and delete observers. Has changed to tell us whether something has changed, notify observers to tell that something really has been modified, or we can send the data along the way. We can say set change to just say, hey, the data has changed, so sets a dirty flag and stuff like that. Well, let's go ahead and say in this case, notify observers, and what are we going to send over here? We're going to send the value that's changed. Well, what's going to happen at this point? If I run the code, the answer is really nothing because we don't have any observers. We only have an observable on our hand. But notice what we will do now. We'll go back to the display stock, and in the display stock, we will say implements, and we will say observer in this particular case. Well, what does the observer require? Well, the observer requires one method, which is the update method. This becomes the observable we are interested in being notified with, and this becomes the data that was given to us. So what are we going to do now? All we are going to do in this case is we'll simply output stock value, and then we will simply display the value, the data that we have received. So this observer simply says, I'm going to be getting the value from this observable, and I'm going to be displaying the data as and when I receive it. So now we can simply go back to the stock and say add observer and add the display as the observer. So if we run the code now, you can see that the particular object is going to be passed to the observer for the observer to start being notified on every different tick or execution that happens along the way. So the display stock is going to be the observer, and that implements the update method that is going to be notified whenever a change happens in the system. Well, now that we have done all of this, let's go back to this code and say, well, we're going to set the notification of change. So we'll say set change to indicate that a change has happened. So we will go back and run this code and let's see what happens. Well, notice now every second there is a new update coming for us. So what did we just do? Let's understand what's happened so far. So if you notice in this particular example, the stock now no longer depends on the display stock. Instead, what just happened here is that the stock becomes an observable, and whenever there is a change in data, it simply notifies its observers, and of course it's told that observers that the data has changed. And in this case, of course, we have said set changed. Let's take a look at what set changed says. Well, the set changed method simply marks this observable object as having been changed, and it's simply going to set this flag called has changed to notify it. Well, the notify observers method, on the other hand, observers, what does that do? Well, that is going to go back and tell its observers. So if this change has, if the object has changed as indicated by has changed, then notify all the observers that a change has been made. And of course, if you say clear change, it would stop sending the change to the objects. So that's a way for you to begin to notify your observers as appropriate. Well, let's go ahead and remove this notify observers for a minute. Let's come back to the start method, and in the start method we will say notify observers. Well, of course I need to say what the value is, so I better go back and put it there. If I didn't have a value to pass, if I just had to notify them to say, hey, a change has been made, you come back and get the value from me, then of course we could simply call the notify observers. But in this case I do want to send a value for the update, so never mind that. So we have the stock over here, we're notifying the observers when a change happens, and of course the rest of the stuff just supports the class itself. The display stock, also notice, does not depend on the stock object directly, though it could. And in this case, of course, as the data arrives, it is going to update the data. What is the benefit of this approach now? Let's say for a minute, let's go ahead and run this. You can see the values are here being displayed, and some value, which is a double value, you can see that value just keeps coming through. But what if I'm interested in not displaying all the values, but I'm only interested in displaying select values? So I'm going to say display select stock, and this is going to be select display. So select display, and this is going to take, let's say, equals new display select stock. So we'll just use this display select stock, and it's going to take in a threshold value. So let's say this is going to be 0.8 for a minute. So let's go ahead and create that select display, and this is going to take a threshold. We'll say threshold, and we will go ahead and set the value for the threshold in here as a field. So now that we have set the threshold, what do we want to do? We'll make this implements observable as well, observer rather. So observer, and so we have an observer on our hand, and that requires us to implement the update method. This is going to bring in the observable one more time, so observable, and this is going to become the data. But what we can do here is we can say double value equals, and we can get the data from it. Again, in this case, we are assuming that the data is actually a double. Probably a good idea to verify that it is. And if the value is greater than the threshold, then we want to output a stock value, let's say exceeds the threshold. So and then we will display what the data is, so which is going to be the value we are interested in. So here is the threshold that we are interested in setting. So let's go back to the code and see how this is going to work. Well, if we go back to the sample one more time, we can now create the stock. And once we create the stock, we have created two kinds of displays on our hand. One is a regular display and the other is a select display. Then we say stock dot add observer. In this case, it's going to be a selected display we added. So if you run the code, you can see every second we are getting notified with the stock value alone, but except when it exceeds the threshold, that prints. So you can see both of these in action, and the two displays are active, but they are being updated by the observable as and when a particular change happens. So this is an example of how we have decoupled the observable from the observer. So what we have in a sense on our hand is there is a dependency between the observable and the observer, but not between the specific classes in the bottom. The stock doesn't depend on the displays. The display doesn't depend on the stocks directly. So that is basically what an observer pattern provides for us. So when an abstraction has two aspects, one independent of the other, encapsulating these aspects in separate object lets you vary and reuse them independently. Now that should probably ring some bells in your ears, because if you think about what we just did, we have an observable and an observer. These two are abstractions, but we have inherited from the observer, observable, the stock, and we have inherited from the observer the two kinds of display. We saw this kind of structure before. If you recollect, we saw this structure in the bridge pattern. But the intention here is very different. In the bridge pattern, our intention was to vary the two implementations and extend them while providing a common interaction on the top. The objective here is that we have a data that's going to continuously change on one side, but we want to notify the other side. So structurally, the behavior and structurally the structure of the observer and the bridge look the same, but the intention is quite different. So you change to one object is required to affect other objects by notifying of the change, but you don't know how many objects need to be changed. You could have many different observers. You could also potentially have many observables also. A display may observe multiple different observers. Rather, a display may observe multiple different observables and also present the data. So object is able to notify other objects without having to know who or what object is changing. This really removes tight coupling. So the force behind observer pattern is open-close principle to decouple so that you can vary the implementations without being affected on both sides. So what are some of the consequences of using the observer pattern? Well, it abstracts the coupling between the observers and the subject or the observable. So the essence behind this is really decoupling of both sides. It supports broadcast operation. So as a result, when a change happens, all the observers get notified right away, and that is one of the benefits you get out of this. But of course, one problem with this is you may actually get an unexpected updates. So there are times when you don't want to receive any updates and you may be notified several times, and the frequency with which you receive the update is decided by the observable and not the observer, and that can become a pain sometimes. But of course, there are other ways you can probably work around it. For example, you could have a little code that says, well, if this is not the time, I could unsubscribe temporarily and resubscribe maybe. It may be expensive and untimely to receive these updates. For example, let's say you're in the middle of updating, and while in the middle of updating you receive another update. What do? Well, typically what you do in a UI is the update will set the data, and it will put a message on the message queue, and then a UI thread may pick the message from the message queue and then update. So if you get too many updates too frequently, that will not end up in a random update of the UI, and so the notifications will take care of making sure that only the update happens when a particular change arrives. But if in the middle of an update already, it will wait for grouping a few updates together before making the next change. So there are techniques to alleviate these pains, but there is still this pain. You may abstract a hint on the subject also. For example, if you are sending an update And if the change is very similar to the previous update, or if the change is something that a particular user may not care about, well, the observer may tell the observable to not only send the updated data, but a hint with it as well. So the recipient or the observer can look at the hint and decide whether it should really care about the data change this time, or maybe it can potentially ignore it. So that gives a little bit more handle on how we would treat these two things. So how does the observer work with some other patterns? Well, mediator may be used to mediate between several objects and the observers. So remember, in the mediator pattern, we were taking the data or the change on one side, and we had to tell the mediator, hey, I want to make this change. Could you please facilitate making the change by coordinating across these collaborating objects? Well, in that case, you really needed the ability to notify the mediator about a data change. Well, we could potentially use an observer pattern to do that if we are really interested in making use of that. So that's when the observer pattern can help us to communicate that very effectively across. Like I mentioned, the observer pattern is pretty widely used in reactive programming. They take the observer and go to the next level. I call that observable plus plus, or an observer plus plus, where the observer can not only notify the recipient, but it could also tell the recipient when there is no more data coming through. And that can be a very powerful mechanism to say, I got data coming through, but when I don't have any more data, I can tell you that there is no more data coming through. Well, in this example, of course, we implemented the observable and the observer using the traditional API. But we don't have to go through that much length. We could also do something else. So for example, rather than the display being displayed like this, let's remove that for a minute and run the code. And you can see in this case, we are not going to get any notification because we did not subscribe any observers. But notice what I'm going to do here. I can simply say over here after the start of the stock, actually before that, I could say stock.addObserver. But remember, the observer is actually taking in the add observer is actually taking in an observer. But if you notice what an observer is, so let's quickly take a look at an observer. If you look at the observer, all that the observer contains is just one single method, which is called an update method. In that regard, according to Java 8, an observer is actually a functional interface. So what we could potentially do here is, rather than taking the time to implement a separate class, we could simply say observable comma data, and then we could simply specify output the data. So we could use a lambda, for example, rather than really implementing a full-blown observer class. So you can see how easy it was to really fill in a lambda for the observer. And so likewise, we can implement various other code logic. So this took care of our display stock. But what about display stock of select value? Well, we could do that as well. So we can simply say, for example, here, add observer and data, and then we could simply say if data is greater than 0.8, then display the data for me, not otherwise. Well, in this case, of course, we are implementing a little bit more logic. So potentially, rather than doing it that way, we could implement this as a separate function. We could, of course, put a curly bracket and write code, but I'm not usually a big fan of that particular approach. So let's go to the display stock for a minute. And here is no more observer in here. We could specify this threshold, if you will, and we could get rid of this method, which is the override, and we could simply say display, for example. Let's say display, and we could not worry about the observable if we don't care about it. And in this case, of course, we pass the data, and it says if the value is greater than the threshold, then display it. Now notice we can simply come back here and say, well, now that we have the data, we could simply say, okay, this is a static method. How about that? So we can simply say, well, actually, in this case, it cannot be a static method because we do need the threshold. So let's use the object we just created. So this could simply be a display dot, and we could say the method update that we just wrote, we called it display, and then we could send the data over to it. So the point really is we did not have to implement the observer interface in the class itself. This could be simply a class that displays the data, but we can then provide the lambda to receive the observable in data and turn around and call the display method. Nothing stops us from passing to the display method the observable if the class will benefit from having that observable, but nevertheless we eliminated the need to implement the observer interface. Thanks to lambda expressions, we can simply pass that down, so you can see that we just received it and passed it. But of course, if the observable it's also being received as a parameter, then in that case we would simply say observable, so observable, and we will call it observable for a minute, and this is going to be the data which is object. So now what happens? Now that we have an observable on our hand, the API becomes a little bit more simpler on this side. So we can simply say, well, now that we have the observable, this will become the observable comma data. So you can see that's going to still work and display only data when it exceeds the threshold. So notice when it exceeds 0.9 or 0.8 rather, it displays the value. But the good news right here is we can eliminate this commonality, and we can use a method reference, and this simplifies the API a little further. So we didn't have to implement the observer interface, but at the same time we got rid of a bit of a ceremony here as well. So you can see the benefit of using the lambda expressions to implement the observer, and so that eliminates some work. Unfortunately, you cannot eliminate the observable itself because remember it's extends and not implements, so we still had to really use extends. We cannot use a lambda for that purpose. Of course, you would have some critical logic in the stock, so you wouldn't want to get rid of it. We saw two things here though. If the display is extremely simple display, we can simply use a lambda, but if the display requires a lot more work, we can still use a lambda or a method reference, but then route to the method that is part of another object, so that can become quite easy to work with. And that is one of the benefits you see with this, is that you can delegate this using a lambda without having to put in a lot of effort in writing this. So observer pattern is quite widely used, like I said, and the force behind this is open close principle. We are decoupling, we are using dependency inversion principle. We also apply the lambda to eliminate some of the noise. Overall, a pretty powerful pattern, easy pattern to implement as well, not very complex, as long as we know when to notify and how do we communicate our intent and make sure that the frequency of update is not too much, then the clients are not bothered to respond. And of course, there are other ways to eliminate that kind of trigger as well, as we talked about in the past. So that brings us to the end of the observer pattern, and as you saw, this is a very powerful behavioral pattern. It is all dealing with how these objects communicate and work with each other, and that's exactly what an observer does, is to help the objects communicate the change and other objects respond to the change as it may happen along the way.